ahead and start with the introduction. So I would like to introduce Cindy Ashforth first. She has over 25 years experience testing and certifying composite structures, and she is one of the FAA's subject matter experts for advanced materials and manufacturing. And then we also have Kirsty Snodderly joining us. She is an additive manufacturing R&D project engineer for ASTM International, and she has over 5 years experience, primarily in medical application and regulatory considerations. I'm going to hand it over to you ladies.
Awesome. So let's make sure you can see my screen. Yes, awesome. And everyone can hear me, correct?
And we can hear you.
Okay, awesome. Thank you. Well, thank you for that very kind introduction. As she said, my name is Kirsty Snodderly, and together with Cindy Ashforth, we are going to be discussing organizations and standards perspectives from the FAA and ASTM. Thank you for joining me today, and thank you to Women in 3D Printing and the TIPE conference for hosting this fantastic event. I'll first start by saying, by giving a brief overview of what we'll be discussing today. I will give an introduction about myself, about ASTM, and then we'll talk about the standards role in industry, and I'll review what the ASTM Additive Manufacturing Center of Excellence is and the promotion of standards development through research initiatives, and then discuss how you can get involved in this community. To start out, my name is Kirsty Snodderly. I am an additive manufacturing R&D project engineer with ASTM International. I have 5 years of experience in additive manufacturing for medical applications. My former position was the additive manufacturing engineer for the Additive Manufacturing Medical Products Laboratory at the U.S. Food and Drug Administration. I have a Master's of Engineering and a Bachelor's of Science in Bioengineering from the University of Maryland. So a little bit about ASTM. ASTM was founded in 1898. That's right, 1898. And we are a standards development organization. The headquarters is located in Pennsylvania, just outside of Philadelphia. And I work out of the DC office, but we have staff all over the United States and all over the world. Currently, ASTM has over 13,000 published standards that apply to almost everything you come in contact with, including areas of construction, aerospace, and additive manufacturing. There are a lot of numbers on this slide, but what I find the most important on this page is that there are over 34,000 members in more than 150 countries, spanning across more than 90 industries. ASTM also provides training courses and trains more than 2,000 individuals each year. So why is this so important? This is important because it shows that standards development is not a one person or one industry task. It takes a team of experts from many different areas and across many different nations with people who have diverse backgrounds that come together and develop a consensus-based standard that allows for improvement within each industry. As ASTM operates internationally, it is no surprise that we have a Diversity Inclusion Council aimed to ensure an inclusive workplace and incorporate a diverse background of our ASTM staff and members worldwide. I think it's really important to share this information today, especially with this group, as each day we strive to further our progress and promote diversity and inclusion throughout our staff, our members, and the world. On behalf of ASTM International, I want to reiterate that we are proud to be a part of the TIPE event. Please join our ASTM President, Kathy Morgan, at 3 p.m. Eastern Time, 12 p.m. Pacific, for further ASTM DEI remarks. So, how is ASTM involved in AM? Well, in 2009, F42, the oldest and largest committee on AM, was founded. Later in 2011, ISO established TC 261 to focus on AM, and the two organizations joined forces since then to eliminate duplication of efforts globally. There are currently over 1,000 members with more than 30% outside of the US, representing more than 35 countries. This committee is broken into subcommittees with more specified focuses, such as aerospace, medical devices, maritime, and oil and gas. And these subcommittees are responsible for the initiation of standards within their specific niches. Currently, F42 has standards for general terminology, specific applications, feedstock materials, process and equipment, and for finished parts. So why are standards so important? Well, standards impact your success in 3 ways. The first is cost savings. You rely on publicly proven standards to save money and therefore increase effectiveness. The second is that shared resources. Standards come together by an industry consensus, and you benefit from sharing resources from many different entities and organizations. And the third way is that it eliminates overhead. By using a trusted process and methodology, you prevent recreating the wheel and unnecessary spending and errors. More specifically, standards development in the AM space allows us to further our goals by enabling the industry to commercialize technology, ensuring trust within the community, and establishing wider AM acceptance by industries. Overall, these standards contribute to the success and growth and acceleration of AM technologies. So the standards development process is a volunteer-run, multi-step, consensus-based approach that begins with the standards need. From there, a small group of people meet to initiate a draft, and then more and more experts are brought in to provide feedback and opinions on that. After a final review and a consensus within the main committee, such as F42, the standard is approved, published, and ready for use within the community. So, how does the Additive Manufacturing Center of Excellence at ASTM fit into this? So first, what are we? We were formed in 2018. The AMCOE is a collaborative partnership between ASTM International and organizations from industry, government, and academia that conduct strategic research to advance standards across all aspects of AM technology. The center aims to accelerate the development and adoption of these technologies by supporting standardization, developing training and certification programs, and providing market intelligence and advisory services. The main objectives of the COE are to coordinate and conduct these R&D efforts that support AM standards development and support education and training of the AM workforce. So how does this fit into the standards development community, and how does this correlate to technical committees such as F42? The AMCOE is leveraged as a platform to conduct research and fill gaps in the standardization efforts. The goal is to identify the standards needs early and provide support for the research efforts to drive initiation of standards and promote the adoption of AM in the industry. So typically, standards development process can be slow, as it's a volunteer process with limited data available to the standards community. There is also a lot of back and forth between technical experts throughout this entire process. By providing this front-end support, the AMCOE is promoting the standards development process by decreasing the amount of time that it takes to go from the standards need to the approval. Additionally, all COE-funded projects are reviewed by ASTM members and rely on inputs from existing roadmaps, such as the AMSC roadmaps. These projects are then selected by F42 members to address the standardization gaps. As of October of 2021, the ASTM Amcoe has contributed to 30 projects with 30 standards either created or impacted. This slide shows some of the key metrics obtained from these projects, including the standards gaps that they've addressed and the work items development, which each work item is in a different, you can see is in a different stage of the development process. But one of the key metrics that I think is important to point out here is that the standardization efforts are being conducted by 17 organizations and 22 technical contacts. These technical contacts represent a diverse group of people and experts, including women, that demonstrate that not only do these projects aim to close these standardization gaps, but they also allow for the training of the next generation of standards developers. Most recently, the COE is supporting 3 projects through our request for idea mechanism and 2 projects through our call for projects mechanism. These projects are 6 to 9 month projects with the goal to generate data that can be used as a basis for standards development process. Additional information about all of these projects can be found on the Amcoe website, which I've linked at the bottom. As there are many gaps in this industry, no one organization can lead them all. Therefore, collaboration is essential. A few examples of the Amcoe collaborative efforts include the 3 projects that we currently have ongoing with America Makes and the cooperative agreement that we have with NASA. These external projects are also driven by the standards needs and contribute to standards development initiatives by encouraging increased collaboration. So how can you get involved? As I mentioned, standards development as a whole and the Amcoe are very collaborative, which means we need your help. In order to get involved in these processes, you can get in touch with the Amcoe through and sign up to our newsletters. You can be involved in future calls for R&D projects, including the RFI and CFP mechanisms that I discussed previously. You can participate in work items that the COE is contributing to or initiating, which we have further information about on our website. Upcoming ASTM COE events are also very useful and and we have them promoted on our LinkedIn and our website. And you can join F42 and impact the standards development process. But we are not just set for these specific ways for you to get involved. If you have additional ideas about how to be involved, please feel free to reach out to us and we would love to have a conversation. The final way you can be involved is to join our team. We currently have 5 open positions that we're hiring for. So you can check out our LinkedIn to view these job descriptions or connect with us during the TIPE at any time during the TIPE conference and career fair. We are located on our ASTM sponsor table is located on level 4. During the network sessions, we'd love to talk and meet with you. I've included my contact information here and other resources on this slide for, take a screenshot and feel free to contact us at any time. But in the meantime, I will turn it over to Cindy, who's going to discuss how industry standards are used during FAA certification of AM parts.
Thank you, Kirsty. Let me see if I can share correctly. Can you see the slide?
Not yet.
Okay. It tells me it's sharing. Let me try again. All right, can you see it now?
Yes.
Okay, so I'm going to continue on what Kirsty was saying about how to develop standards and say, what do we do with them? And I'll begin a little bit just talking about why it's so important in the world of additive manufacturing to expect to use and rely on standards. So, there are some AM-specific attributes that make it unique
Hey,
from
Cindy.
traditional materials, at least when we're
Cindy,
looking at it
just
from a,
Cindy,
yes.
just so you know, you're sharing you're just the actual slide deck, so you're not advancing your presentation screen.
Okay, it told me it was sharing the screen. Let me try one other way. Well, all right, I can't put it in presenter view apparently, so let me try to enlarge version and see if that'll work. Some AM, so this was, sorry, the AM specific attributes. There are plenty of things that make AM a little bit unique to traditional materials, but what you will learn is that our regulations don't change. It's just the way that you meet the regulations that is different because you're using additive manufacturing. And this isn't the first rodeo for the FAA and other regulatory agencies either. There are many elements of additive manufacturing that are common with other advanced manufacturing methods, such as composites. And this is where our regulations don't really address these items, but yet we realize that the applicant does have to figure out how to deal with them. And that's where the subject of standards, industry standards, becomes so important. So as an example, we have a regulation for material strength properties and design values. And it says that it must be based on enough tests of material meeting an approved specification. An approved specification, well, I think we all realize you need a material spec and you need a process spec, but what actual information belongs in there? What makes it, what makes it approved is that it becomes part of your design. But when it comes to the details of what needs to be in there, and that runs the gamut. Some companies think they can get away with just listing a material, brand name or a Ultim 9085 or something like that, and without giving more details. And that just isn't going to work in the aviation industry. So this is where, an approved specification, ASTM has specifications, SAE has specifications, I'm sure other organizations may as well, that, that really help. Either if you want to create your own standard, you can, but at least they give you the type of information that we would be looking for. Now, the FAA does not approve industry specifications. There's no way to get pre-approved in that manner. All we can do is approve it each project. But if you use an industry standard specification, you can feel pretty confident that you're going to have the information that we're looking for. Another example, this regulation requires fatigue and damage tolerance, that you will avoid catastrophic failure due to fatigue, manufacturing defects, and accidental damage. Here too, industry standards can be used to help ensure that you do not have these events happening. You don't want catastrophic failure. You don't want manufacturing defects. You don't want fatigue and corrosion. And how do you prevent that? And that really begins with solid material and processes. And but even other certification procedures can be part of industry standards. Another area in the engine world, which is heavily laden with additive manufacturing parts, you have to have engineering, manufacturing, and service management plans that work together to ensure that you do not have service failures of, well, any part, but what do we do when you have to develop an engineering plan, a manufacturing plan, and a service management plan for additive manufacturing, especially when it's new? You have no service data to rely on. You're creating it from scratch. And that's where industry standard has been particularly useful. And in this case, it was an AIA, Additive Manufacturing Working Group report on recommended guidance for certification of AM components. And this came out in 2019, I think it might have been, 2020. And it gives best practices in the areas of M&P development, part qualification, and development of material allowables and design values, all of which you have to do to certify a part on an airplane. And we're very happy that AIA put this report together. And it's something that if you follow, you can expect that it's something the FAA would be satisfied with for many applications. AIA is the one that came up, or they documented the process of doing this development, supply chain qualification, properties, part design qualification, and then quality control. It's very similar to what we've done forever in aviation, but just making sure now that it's well documented how these philosophies are applied in additive manufacturing world. Why are standards so important? Because the FAA is not publishing much anymore, is the truth. Right now, we have a policy from it's government-wide policy that we must use voluntary consensus standards in lieu of government unique standards in our regulatory activities. And we have to report to NIST and the OMB when we elect to use or develop our own unique standard in lieu of a industry standard. In addition, we have the Faa Reauthorization Act that says our guidance and policies are supposed to be based. And performance-based is great in so many applications, but sometimes you really need the details. How many tests do I have to perform of what materials in what orientation with what build process, what is the minimal information for different documents? Those details really become important at some point. And if it's not in anything that the FAA publishes, that's where we need the industry standards. Useful places for industry standards, material and process specifications are the most obvious one, but qualification processes for facilities, equipment, and personnel, repair, huge area for additive. But best practices is something we also like to see. What are lessons learned in design and structural substantiation? What worked, what didn't work? And then, of course, material databases are going to be important in the additive world. The FAA is actively involved with the AIA, AM working group that I already mentioned. We too partake in America Makes, the American Welding Society S20 Committee, ASTM F42. We support many of the working groups. The ASTM COE, we're on the advisory board, R&D team, the Engineering Workforce Development team. We are part of the CMH 17 AM Coordination Group, as well as MMPDS, their Volume 2 activities. We join a lot of our research with CART and then SAE, Additive Manufacturing Committees. We support all of those as well. We also have a fairly large research portfolio of what the FAA sponsors in both polymer and metal AM. To point out again, MMPDS is creating volume 2 for process-intensive materials, so that'll be databases, statistics, methods, and best practices. CMH 17, which is the Composite Material Handbook, they actually have a new volume to provide non-metallic additive manufacturing material data, describe how to generate the data and how to use it with proven best practices. ASTM F42, the ASTM Center of Excellence, SAE committees, and then we have several projects where we are creating databases, including standards for material and process specifications, and as I said, best practices. So in summary, we really plan to leverage our existing regulations and lessons learned with other advanced materials to the greatest extent practical. Industry standards organizations are encouraged to develop standards that support regulatory compliance. We believe that it promotes safety, and we hope that they focus on means of compliance to existing regulation. M&P controls are definitely the fundamental place to begin. And then we need to talk about, when we develop material and process controls, how are these scaled for the degree of rigor for a specific material and process control? For low criticality applications versus high criticality, we shouldn't always have to meet the same standard. Again, MMPDS and CMH 17 are both developing new volumes, which will have significant information. And, one pitch, if we could get industry standards organizations to collaborate and coordinate to reduce overlap, that would be fantastic. But the most important thing is to make sure we don't have any inconsistencies in guidance. So. That's it for our presentation. Do we have a minute for slides? Or questions, I'm sorry, questions and answers.
We are just about out of time. Cindy and Kirsty, thank you so much. I think we will go ahead and ask one question, if you guys can answer quickly, that had a lot of votes. What is the best way to get involved in standards development if you don't have industry experience but still want to learn?
I can take this one. So at least to start, if you want to add anything at the end, Cindy, let me know. But the best way to get involved in standards development process is to join a technical committee. For example, F42 for additive manufacturing. That will allow you to be involved in the different processes and of the standards development process overall, and help you learn how things work. Do you have anything to add, Cindy?
No, I mean, any organization, they do not require experience. As I'll speak a little bit for CMH 17. We're happy to have novice practitioners join handbook activities simply because as we write content, you can still review and read it. And if it doesn't make sense to you, there's something wrong with what's being written. So novice people can be great editors to make sure that the standards are going to work.
Yeah, absolutely.